Welcome back, everybody. Hopefully after watching my last video, you're now experts on adding and subtracting matrices together. I mentioned at the end of the last video that this video is going to talk about how to enter matrices into our calculator and have the calculator do work for us. But before we use the calculator, I think we need to talk about matrix multiplication, and then we'll talk about the calculator in the next video. So when we talk about matrix multiplication, there are actually two different forms of multiplication. We have scalar multiplication, and we have matrix multiplication, which is when we're going to be multiplying two matrices together. So let's first talk about scalar multiplication. Okay, so we need to know, first of all, what is a scalar before we talk about scalar multiplication. So a scalar is just a number that we're going to multiply by a matrix. So for example, if we have the matrix A, let's have A be a 2 by 3 matrix. And so we'll just plug in some values here. Remember, a 2 by 3 matrix from the last video needs 2 rows and 3 columns. So we're going to just plug in some numbers: 2, 3, 1, 5, -4, and 8. So this has 2 rows, 3 columns. This is a 2 by 3 matrix. Okay, so scalar multiplication would say, what happens if you take the matrix A and just multiply by 2? So we're looking for 2A. Now 2A, it would seem that this scalar multiplication is actually probably a little bit more intuitive for you. So what we're going to do is basically we're going to take all of the entries, all of the components, or all of the elements in A, and we're going to multiply each one of them by 2. So we're going to have something like 2 times 2, 2 times 3, 2 times 1, 2 times 5, 2 times -4, and 2 times 8. And so we're just going to take each entry, each component in the matrix A, and just multiply by 2. And we're going to get a new matrix. And notice this new matrix is also going to be a 2 by 3 matrix. When we simplify this out a little bit, let's multiply our numbers together. We're going to have 4 up in the top left. You're going to have 6, 2, 10, -8, and 16. And so there's your new 2 by 3 matrix. Notice all of the values in our matrix A just doubled, because we just multiply by 2. So scalar multiplication is pretty straightforward. We're just taking each of the entries in A and doubling them because we're multiplying by 2 here. Now, something I don't think we talked about in the last video, if we look at just a single value in this matrix, I'll circle the -8 that's here. Notice that this -8 is in the second row, because it's down here in the second row. It's also in the second column. So we can talk about the placement of a value, or the placement of a component in a matrix. We would say that this value right here, this -8, we're going to use a little letter a, because the big matrix is called big matrix A. If the big matrix was capital B, we would probably use a lowercase b here. So this is, we'll call it little letter a, and it's going to be A subscript 2 subscript 2. Just like when we used a 2 by 3 in the bottom right to talk about how many rows and how many columns there are. Here we're going to label this component as being A sub 2, 2, to say that this component, or this element here, is in the second row and the second column. So what we're doing when we do scalar multiplication is we're taking each of these elements, each of the components, each of the aij's, or the A, we would have 1, 1, or A2, 2, or A2, 3, are going to tell us which row and which column the place that component is in, and then we're going to take each of those components and multiply by 2. Okay, so let's see another example here. So in this next example, we're going to take a matrix B, and let's have this matrix be, how about a 2 by 2 matrix? We're going to deal a lot with 2 by 2 matrices. We're going to deal some with 3 by 3 matrices. So a 2 by 2 is a pretty standard size. That's actually a pretty small matrix, considering can't get much smaller than that. So B is 2 by 2. We're going to have 2, 3, -4, and 1. And if we find -3 times B, okay, go ahead and take a minute, pause the video, and work on find -3 times B. What do you get? Okay, welcome back. So what did you get when you do -3 times B? We're going to take B and just multiply every single value in the matrix B. So we're going to take the 2 and multiply by a -3. We're going to take a 3 and multiply by a negative 3. We're going to take a negative 4 and multiply by a negative 3. And we're going to take a 1 and multiply by a negative 3. So again, what we're going to get out is a 2 by 2 matrix, where we're just taking each of the components in B and multiplying by a negative 3. So we're going to end up with a negative 6, a negative 9, a positive 12, and a negative 3 right there. There's our new 2 by 2 matrix, which is negative 3 times B. All right, now that we've talked about scalar multiplication, we're going to talk about how to multiply two matrices together. It's our second method, is matrix multiplication. And this is going to be kind of counterintuitive. This isn't going to happen the way that you think it probably should. So this is going to be a little bit interesting here. The way that we multiply two matrices together actually looks like this. If you have a matrix A, let's say A is a 3 by 2 matrix. We're going to have 2, 1, 3, 4. We'll just use some pretty simple numbers here. So here is a 3 by 2 matrix A. In order to multiply A by another matrix, we need the other matrix to start with the same number that the A ends in. So we need B to be a matrix that starts as 2 by something. Here we'll say a 2 by, let's say a 2 by 2 matrix. And we'll have B be this matrix of 1, 2, 3, 4, I guess. We'll just go right in order. So here we have A and B. And in order to multiply A and B together, we're going to say A times B. But this isn't going to go quite the way you want. Notice when we added and subtracted matrices, they had to have the same size, meaning they had to have the same number of rows and the same number of columns as each other. That's not true in multiplication. We can actually multiply these two matrices together and do A times B, even though A has 3 rows and B only has 2 rows. What matters is that A has the same number of columns as B has rows. Because the way that we're going to multiply A times B together is we're going to take the first row in A and we're going to multiply it by the first column in B. Now when we multiply the first row in A by the first column in B, we're going to take the first entry in A and the first entry in B and multiply those together to get 2 times 1. And then we're going to add multiplying 1 times 3. Now this isn't multiple different components in the new matrix. This together, this 2 times 1 plus 1 times 3, is just one component in the new matrix A times B. Okay, so we're going to do that again when we look at the second row and the first column of B. We're going to have 3 times 1 plus 4 times 3. Okay, the 3 times 1 and the 4 times 3, and add those together. We could also multiply the third row and the first column together. It's going to be 0 times 1, 0 times 1, and then add it with negative 1 times 3. So this is the whole first column of our new matrix. Now notice we haven't touched this other column over here in B. We haven't touched the column 2, 4. Really, we're going to take all 3 of these rows and multiply by each of the columns separately in matrix B. And I won't go into a whole lot of detail of why this works. We're really just kind of working on how to do some operations here. We could go into a lot more detail on that. I'm sure there are other videos out there on why we're doing this in more detail. But we're going to take each of the 3 rows in A, and then after we multiplied by the first column in B, now we're going to multiply by the second column in B. So we have 2 times 2, and we're going to add that to 1 times 4. So again, this doesn't quite work the way that you would think. It seems like you should think about, oh, maybe if I just multiply the first components in A and B and I'll be good, that will give me the first component in the new matrix, but it actually doesn't work out that way. So we're going to take the second row in A, multiply by the second column in B. That's going to give you 3 times 2 plus 4 times 4. And then we're going to take the third row in A and the second column here in B. We're going to have 0 times 2 plus a negative 1 times 4. So notice in the first column of the new matrix, you have a 1 and a 3, a 1 and a 3, a 1 and a 3, because the 1 and the 3 showed up in the first column of B. In the second column of B, you're going to have a 2, 4, 2, 4, 2, 4, because the second column of B is 2, 4. Okay? So this is going to be our new matrix. Now, you'll notice that what we end up with is not a 2 by 2 matrix like B was. Okay, so when we do some multiplication and then add things together, here we're going to get 2 times 1 is 2, plus 1 times 3 is 3. So 2 plus 3, we get 5. So order of operations here. Here we'll just complete this. 4 plus 4, we get 8. Okay, 3 times 1 is 3, plus 12, we're going to get 15. 0 plus a negative 3, you're going to get negative 3. Okay, so there's our first column in the new matrix. Over here, you're going to have 3 times 2 is 6, plus 4 times 4 is 16, so we're going to get 22 right there. 0 plus a negative 4, you're going to get negative 4 in your last entry in the new matrix. So A times B here is now a 3 by 2 matrix. Now, if you notice, in the original, we had A was a 3 by 2 matrix and B is a 2 by 2 matrix. Now this isn't a the result isn't a 3 by 3 matrix just because A was a 3 by 2 matrix. What we're going to do is A is 3 by 2, B is 2 by 2. These middle numbers need to line up because you need to have the same number of rows in A as you did columns in B. If these two numbers don't line up, if they're not the same number, then we actually can't do the multiplication. This will be an option on some of your homework where it will say, can you even multiply these matrices together? And an acceptable answer could be no. If those middle numbers don't line up, then you can't multiply the matrices together. All right, so here are the same two matrices, A and B, that we just looked at. And what we just found is that A and B, if we multiply A times B, because A is 3 by 2 and B is 2 by 2, we can actually do that multiplication. That works out okay. But if we try to multiply B times A, notice B is 2 by 2, A is 3 by 2. These middle numbers don't line up, and they're not the same, and so we can't actually multiply those together. So there's no way to be able to multiply these. Now this brings up a really interesting point. A times B works, but B times A doesn't work. That means that matrix multiplication is not commutative. This is going to be a really important property for us as we move forward, because when we have things like addition of real numbers, 2 plus, if we talk about A plus B, that's the same thing as B plus A. We have commutative property. A times B is B times A. And with matrices, capital letters, A plus B is always going to give you the same thing as B plus A. So matrix addition is commutative, but A times B is not necessarily B times A. So we can't swap around the order when we're multiplying. We need to keep that in mind. This will be a very important property for us as we keep moving forward. Alright, thanks for checking out this video. You should head on over to the next video, which talks about how to use your calculator for matrix operations.